Hello and welcome to Differential Discussions. I'm Melissa,
And I'm Dave.
and we're back with another CSF.
Quite a colorful CSF so far.
Yeah, quite an ugly dark CSF.
Yeah, so like instantly when I'm like, oh, it's time to look at a CSF, I expect to see like lighter coloration, right? This is punch me in the face kind of dark colors. So that's a thing. What is that? Oh my goodness. All right, we're gonna keep scanning and be disciplined, but wow. This is really bad. So we're looking for clumps of cells.
So I'm not sure there's a good area anywhere really to start.
No, yeah. I think the bad stuff is going to follow us a little bit here, right? So
Okay, let's just pop down to 40.
although at some point I would like to visit that giant
The giant ball.
the giant ball.
You go back.
Yeah, that one's perfect.
You can see the ball on 10. That's so funny.
Mm-hmm.
Okay. So this is 40, and this is this giant
Yep.
ball here.
Yep. Yep. Okay. So yeah. So again, remember that cells have a three-dimensional aspect to them. So this looks a little less than what I maybe expected it to look like, but I don't really know where to go with this without kind of just coming out with it. But
Well, I think
there's like,
people can tell.
yeah, there's a real suspicion of tumor here,
Yeah.
right? So you see this, I would say more frequently in pleural fluids,
Yeah.
where we have a tumor in the pleural space, and we'll get these three-dimensional kind of clusters of cells, and they'll just look like this big blue kind of blob. And when you go down to look, you can't really pick out the individual cells particularly well, but you can see that there's like a height, a depth to it, right? And so you can imagine a tumor that's growing out of control. They don't just grow in one direction; they kind of just tend to kind of go everywhere. So having that depth and stuff to it is not unusual.
This little cluster right here is a pretty good.
Perfect example, right? So we can see there's nuclei in there, and we can see that there's cells, and that there's like a height and a depth to it. And we can also see around here that the cytospin has successfully kind of, smushed the cells down to the glass and things like that. So yeah, this is highly suggestive of a tumor. Yeah.
These are so ugly.
Oh my God.
All right, let's just start here. I'm gonna drop down.
Sure. Yeah, I think we're ready for oil here. All right. So we have monolayer cell cytospun, and I cannot see anything inside that cell. Okay. So now let's rewind. I have a cell right next to it. I can see the cytoplasm clearly. I can see the nucleus definition clearly. I can see how red cells are staining. This right stain is behaving exactly as it's supposed to. If you make another slide on this, that's cool to have extra slides for this because it's wonderful to teach. This will not change. You can't make this go away, right? If I could make cancer go away by making more slides, I would make lots of slides, right? This is troubling. Very troubling.
Yeah, and with most of these slides, you can't tell where the nucleus begins and the cytoplasm ends. You
Yep.
don't see any real detail in there. It's super dark, super ugly, and once again referencing like this is what heterochromatin, or I don't know that the cell is normal, but like
I think it's cancer too,
I
but
think it is too, but like you can see like this is more of the image that you want with like you can actually see the chromatin pattern or even this. I mean this looks malignant too, but you can see the chromatin pattern.
yep,
These you can't see anything.
yep. And that's just not the stain.
Right.
That's the cell. So yeah, everything in this field is going into other. And man, it looks like just about everything in this slide.
Yeah.
Horrifying, right?
Let's
Like,
see if we can find something that's semi-normal. Meh.
yeah, I mean,
I mean this one right here, right?
maybe a lymph there, right?
This little lymphy guy. And
Yep.
I don't think I can let me try this.
Yeah. This, that ain't good, man. This the darkness of the nucleus, the shape.
Oh, look at
Um,
this one. Look at this nucleoli. It's like, oh, yeah, let me get my little drawing dude out. It's literally like this. And then you've got this other one like right there. For a nucleoli.
not good. This one has prettier contours, but still, let's
Yes, and you can see the chromatin, but it doesn't still doesn't look normal.
yeah, definitely not. And again, these are a lot of these are looking like tissue
Yeah.
cells, and we should not be seeing tissue cells for this. Yeah. Yeah, like I mean, there's even like these smaller cells. Like, what the heck am I even gonna call that thing?
I know. It kind
I,
of it almost has the same like granular pattern to the last one that we looked at that had some cancer cells in it.
yep. So we had one other CSF that we reviewed that had less numerous abnormal cancer cells that had these kind of pro-looking kind of colored granules. Um, this is these are all WTF cells, to be frank. I mean,
Yes. And some of them are very large, some of them are very small. And honestly, I think that's just a product of them going through mitosis. And sometimes we catch them like right after they've gone through mitosis. So they're very small. And right
mhm.
before they go through mitosis. So they're very large.
Yeah. Yeah. So there's a saying I throw around a lot, birds of a feather.
Mm,
And you might start to see that, oh, maybe there's several different populations of cancer cell here. Well, that's not unheard of either. I mean, cancer cells' genomes are anything but stable.
yeah.
So it's not crazy at all for you to start to see as it progresses. I mean, I'm not in the business of doing medicine, but this looks like very, very advanced disease. Um,
I mean, I'm perusing around and just seeing cancer cells. So I'm
yeah,
just kind of moving around as we're talking because if we can find something normal, great.
yeah,
But
yeah.
really, it's just these ugly, and we keep saying ugly because they are. They're really dark. Oh, look at, I mean, this guy looks like he's going through mitosis.
1000%. So now we have mitotic figures. So depending on the lab that you're in, that's somewhat significant finding. It doesn't always suggest malignancy, right? The normal lining cells go through mitosis. That's how they keep tissues kind of functioning and replace themselves. But even the mitotic figures in that cell looked abnormal.
There's another one.
And
And it looks like this. I'm wondering if that might have been a normal Dendropa.
maybe.
Kind of hard to tell.
This is one of those things where it's like I might throw in just like the token, like I'll give you the benefit of the doubt. There's a normal hematopoietic cell, whatever.
A neutrophil.
Yeah. Yeah.
Maybe.
But yeah, this is
Oh,
absolutely dominated by cancer cells.
this looks like
Ooh,
leukophagocytosis.
it's a phagocytized like cancer cell kind of thing. What's going on here?
So this is the thing, like we can't tell. Is it an actual normal macrophage doing its job, or is it a cancer cell eating another cancer cell?
Oh man. Yeah, I mean, so
And it looks
so
like this cell is necrotizing,
yep.
dying over there, which usually cancer cells lose the ability to go through apoptosis, so they just kind of die in circulation. So that
Yep,
wouldn't be surprising.
yep, not surprising at all. Yeah, yikes. I kind of like my intuition, or I want to believe that this is a macrophage that's eating the cancer. Good job. Fighting the good fight. But it's a losing battle. Yikes. More mitotic figures, more ugly.
So like these
Yeah.
these guys up here, let me pull them a little bit in better. This one is hard to tell if this is a binucleate cell, like it's just got two nuclei in there, or if this is two separate cells, because you can't see where like their cell ends and cell cytoplasm begins.
Look at the gargantuan.
Yeah,
I don't know if we call it. That is just
I did. And how about
ridiculous.
this one? It's like I know.
Yeah.
Oh my goodness.
Very, very abnormal. Yeah, the differential on this one is basically just doesn't matter. It's basically all cancer cells.
Yeah.
It's a shame.
I think we've seen like what maybe one normal-ish
Yeah,
cell.
maybe a lymph, maybe a neutrophil, right? But
Wow.
yeah.
And really, uh, again, in the last video, we described a lot of the what the cells are going to look like, what their characteristics are for more malignant cells. But again, like lacking the nuclear. Where does the nucleus end? Where does the cytoplasm begin? Having the nucleus have weird undulations, having the darker chromatin pattern where you're really unable to see it detail, and then having ugly shaped nucleoli, the really ugly blebbing, not like the nice blebbing where you could tell it was just lining cells kind of doing this, but really ugly blebs, the deeply basophilic cytoplasm, all of these things are lending themselves to being these malignant cells.
Yeah. 100% agree. I think
Okay.
this about taught us everything it's going to teach us, eh?
I think we're just going to see more of the same.
Yeah.
All right. Well, I think that's all we have for this one. So thanks for watching.
Thank you for your time.